Welcome back, AP Calc teachers, AP Calc students out there. Sup? We're going to take a look at another Continental Math League problem. This time we're still working with the 2022-23 test from Meet 2, and this is problem number 6. And if you're my students and you're watching this, it is very likely that we are still working within Unit 6 of the course and exam description from the College Board. And it turns out that in order to solve this problem, you're going to need some information from Unit 7. This particular problem, I'm going to type this in, is what we call a differential equation. All right, that's the entire title of Unit 7. And it just involves using the integral and a few other little twists and turns in order to find an actual solution curve. And so I'm going to go ahead and walk you all through this. I might give you a little bit more kind of detail with this particular problem, as it is a bit out of the realm of some of the things that we've talked about. But I think you're going to be able to understand this, and it's a great introduction to what we're going to do in Unit 7. So it says the slope of the tangent to the curve f of x equal y is given by xy squared. Okay, and so if we just stop right there and translate that into mathematics, slope, the word slope in calculus means the derivative. We can use notation for the derivative that looks like this, and it's going to be best that we use the Leibniz notation, dy over dx, and that's equal to x times y squared. Now the problem goes on to say if the curve passes through the point 2, -1, find the positive value of x when y is going to be -1/3. And I know that this problem is a little bit extra tricky because it's not multiple choice. So the very first thing that we must do with a differential equation, an equation with a derivative in it, is to separate the variables. We're going to put the y's on the left side, and we're going to put the x's over on the right side. So that means we're going to divide by y squared, moving him to the left, and we're essentially going to multiply, for lack of a better way to describe it, the dx over to the right. Now, I don't want to open up a big can of worms with all of the people out there that are saying, no, you can't really multiply by the differential. You know, we can manipulate it in that way, and it's not going to break the problem. All right, so I'm going to kind of use that terminology about multiplying the dx over, because I know it's going to work for us. Now what you all need to do is take the antiderivative of both sides. That's going to get rid of all those dy dx things. And what we're going to eventually want here is an equation for y. So when you take the antiderivative of y to the -2, right, if this guy was dreaming, he would be dreaming of being written as y to the -2 power so that we can integrate him better. And we get y to the -1 over -1, of course. And then on the right side, we integrate x, and that's just simply x squared over 2. Now, we do need to introduce a plus c somehow. And there is technically a plus c on both sides, but we can consolidate those plus c's together. Let's put them on the right for now, okay? And I suppose we could clean up the left side just a little bit to get this. Now, guys, what you have right here is called the general solution of a differential equation. It's actually how some of the beginning stages of Unit 7 look. But we want a very specific or particular equation at that ordered pair. So what I want you to do is you're going to plug this ordered pair in. The 2 is going to plug in for the x, and the -1 is going to plug in for the y. And if all goes well, you should find yourself a c. Okay? And so you'll have some equation now that looks a lot like this one, except you're going to know a c value. Now, what this problem wants you to do to finish it up is to let y equal -1/3 once you find that c, and then solve for the x. Now it gives you a little hint that I want the positive value for x, so it sounds like to me there could be a plus minus maybe going on with that solution, yeah, I probably see that because x is being squared. Only give me the positive answer for that. And I will give you a hint. It's not a pretty number. It will have a square root involved. All right, hopefully that gives you enough help. If you need to kind of stop, pause, rewind the video and listen to that hint again, feel free to do that. But good luck with number 6. For many of you, that's the first differential equation problem that you've solved. We'll see you next time.